Hello everyone. Today we are looking at another Leetcode problem 2311. This is longest binary subsequence lesser than or equal to k. Now in this problem we are given a binary string s and an integer value k. Now what we're expected to do is return the longest subsequence of binary string s that makes up the binary number lesser than or equal to k. What that means is that if I have a binary number, let's say something like this, I can pick non-consecutive elements and create a resulting binary number, which in this case looks like this. Now, I have to check if the decimal value of this subsequence is lesser than or equal to k. And for all such subsequences that are lesser than or equal to k, I have to find the maximum length or the longest subsequence. Now, we got to note that leading zeros are acceptable. An empty string should be treated as 0. So, the challenging part of this problem is figuring out the execution flow. Now, let's say I have 111. And if I start to process this from left to right, then I take this one and I haven't seen anything on the right hand side, which means that I take this one and multiply it by 10 power 0 because this is the first one I've seen. Now when I see the second one, I know that there is another one on the right side of this. So the value of this now gets multiplied by 2, and then we have plus 2 power 0. Now further, when we see this, we multiply another 2 to this, another 2 to this, and then we add 2 power 0 here. Now see what happened here. As we were traversing left to right, for every element that we were seeing, we had to adjust all of the previous values that we had earlier discovered. So one of the key takeaways is that this problem needs to be solved from right to left. Okay, so again, if you had 111, what I would do is 1 into 2 power 0 and add that into 1 into 2 power 1 and add that to 1 into 2 power 2. So this gives me 1, this gives me 2, this gives me 4, and I add them up to get 7. Okay. Another important thing to note in this problem when we are trying to find the longest subsequence is how do we really create a longest subsequence of the same value k. Okay, maybe let's not take the value k because here it has a meaning with this question, but let's say that I have two binary strings 0 0 0 1 and then 0 1. Okay, both of their values is 1, but this one is clearly longer than this one. Thing to note here is that zeros on the left don't add to value. So this is something that we can take advantage of. But that said, we have to be really careful. Zeros on the right hand side do add to the value. So this one is now 1 into 2 power 1 as compared to this, which is 1 into 2 power 0. Okay, so this is something that we'll have to take care of. Now, what we have to do is find the longest subsequence of value lesser than or equal to k. Okay, so max this value can go up to k and min this value can go up to 0. Okay, what is minimum of 0? All zeros. A subsequence of all zeros gives me min of 0. What is max of k when I start to pick up some ones in between. Okay, something like that. When I start to pick up, maybe let's make it equal 0. When I start to pick up some zeros in between, the value increases and I can reach maximum value up to k. So given this understanding of the problem, what we can now do is that we can find the count of zeros, zero count, okay, and then from right to left, we can keep picking ones, ones till value is lesser than or equal to k, but we cannot go beyond k. Okay, so now let's quickly get to the pseudocode which will cement all of these concepts. Okay, so we say n is equal to len of s, zero count is equal to sum of 1 minus integer of value for v in s. Okay, so what we are doing here is we are reversing. If we had a 0, we are making it 1, and if we had 1, we are flipping it to 0. So we'll end up counting only our zeros. Next, we got to count our ones. So initially we have that as 0 and value is also equal to 0. So we say for I in range, let's read from right to left. So n minus 1 to minus 1 minus 1, reading it in reverse order. If s of I happen to be equal to 1, then let me check what is the value addition of this new thing. So if value plus 2 to the power n minus 1 minus I is greater than k, then I break. Okay, so what is 2 to the power n minus 1 minus I? Okay, so the first thing is we are trying to read in the reverse order, and in the reverse order the powers are growing like this. Okay, so you can think of this is the reverse index, but you want it in 0 index order. So if this was n minus 1, okay, then what you're saying is n minus 1 minus n minus 1 gives me 0. N minus 1 minus n minus 2 gives me 2, right? So if this was 6, 6 gives me 0. 6 5 gives me 1. 6 4 gives me 2. So when you read it in reverse order, you're creating this 0-based index, which then gets raised to the power, and that's how we are getting the previous value plus current value, and we are evaluating if this happens to be greater than k. If this happens to be greater than k, that means we cannot take this 1 and we break. But if we could, if it was still lesser, then we say one count has gotten incremented. And my value has also gotten incremented. Okay. Now once this has been done, once I've counted my zeros and ones, I just return the sum of 0 count and the 1 count. So now if you think about the time complexity, we are spending time here to scan the full S. So this will give me order of n, and then here we scan again, and this time we compute the value to count the 1 count. So this one is order of n for counting 1 count, and so the total time complexity is order of n plus order of n, or if I have to write it, is order of n plus n, which gives me time complexity of order of n. That's about it for this problem. I'll see you again with the next one. Thank you.